In this example, I need to find f of g of x and g of f of x, and also determine whether the pair of functions f and g are inverses of each other. We're given that f of x equals 3x minus 2, and g of x equals x plus 3 divided by 2. So to start with, we need to find f of g of x. Remember, we work from the inside out, so I'm going to replace g of x with its definition. So I'm going to get f of, instead of g of x, I have x plus 3, all divided by 2. So now, to evaluate f at x plus 3 over 2, I go to the definition of f of x, and if you get confused with all these x's, remember the x is just a placeholder. And what do I have to put in that placeholder? X plus 3 over 2. So I'm also going to have to replace this x with x plus 3 over 2. So I'm going to get 3 times, instead of x, I'm going to have x plus 3 divided by 2, and don't forget the minus 2. So now all I have to do is simplify this expression. Since I'm multiplying 3 times a fraction, I'm going to turn 3 into a fraction by dividing it by 1. Nothing reduces here, so I'm going to distribute the 3 in. So I get 3 times x is 3x plus 3 times 3 is 9. All divided by 1 times 2 is 2. Now I'm going to have to subtract 2 from this expression, so I'm going to need a common denominator. My common denominator is going to be 2. So I'm going to turn 2 into a fraction by dividing it by 1. Then I have to multiply numerator and denominator by 2. So I'm going to get minus 2 times 2 is 4 over 2. So now simplifying this expression, I get 3x and then 9 minus 4 is positive 5. So I get 3x plus 5 over 2. So f composed with g of x is equal to 3x plus 5 divided by 2. Next, I need to find g of f of x. We're going to do it exactly the same way. I'm going to replace f of x with its definition of 3x minus 2. So I'm going to get g at 3x minus 2. Now to evaluate this, in g of x, wherever you see an x, I'm just going to put 3x minus 2. So instead of this x, I'm going to get 3x minus 2 plus 3, all divided by 2. And this simplifies to 3x, negative 2 plus 3 is positive 1, all divided by 2. So g at f of x is equal to 3x plus 1 all divided by 2. In the last part of the problem, we need to determine whether f and g are inverses of each other. And the way we do that is to show that f and g are inverses of each other. We must show that f of g of x equals x and g of f of x equals x. Well, in this case, f of g of x definitely did not equal x, and neither did g of f of x. Therefore, in this problem, we know that f and g are not inverses of each other. And one last thing I want to point out is if this problem had been phrased differently and it had just asked us to determine whether the pair of functions f and g are inverses of each other, directly we got this first result of f of g of x not being equal to x, we immediately know that f and g are not inverses. We wouldn't have to do the second part of the problem.